for today's lesson, we are going to learn how to graph sine and cosine functions. So the first thing we're going to do in our warm-up is going to be our foundational skill that we need in order to graph sine and cosine functions. And that is, I would like you to please evaluate the following 10 functions. So the first thing that we have is the sine of 0 pi. Then I want you to calculate what the sine of pi over 2 is. And then I want you to come up with what the sine of pi is. Then I want you to come up with the sine of 3 pi over 2. And then finally, the sine of 2 pi. So those are the first 5. The next 5 I would like you to evaluate is the cosine of 0 pi. 6, 7. We have the cosine of pi over 2. Hopefully you're looking at this and seeing a pattern. We have the cosine of pi. The 9th one is the cosine of 3 pi over 2. And then for 10, we want to come up with the cosine of 2 pi. So I would like you to please go ahead and pause the video, and I would like you to please evaluate each of these individually. And then I want you to restart the video and we will compare your answers. Okay, so hopefully you're looking at and recognizing that these values are all coming from the unit circle. So the 0, pi over 2, pi, 3 pi over 2, and 2 pi are all our quadrantal angles. So if we think about going around our unit circle, at 0 pi, we have the ordered pair 1, 0. At pi over 2, we have the ordered pair 0, 1. At pi, we have the ordered pair negative 1, 0. At 3 pi over 2, we have the ordered pair of 0, negative 1. And then we're right back at 1, 0 again once we reach 2 pi. And hopefully you remember that all of our sine values are the y values of these critical values. So if we wanted to calculate what the sine of 0 pi is, that is going to be the y value, which is 0. Sine of pi over 2 is 1. Sine of pi is back at 0. Sine of 3 pi over 2 is at negative 1. And the sine of 2 pi is at 0. The cosine values, those are just the x values of our ordered pairs. And the x values, starting at 0 pi, is 1. Pi over 2 is at 0. At pi, it's negative 1. And then at 3 pi over 2, we're at 0. To go back to 2 pi, we're back at 1 again. So the cosine of pi is, or 0 pi is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is back at 1 again. And these are our foundational values that we're going to be using in order for us to graph sine and cosine functions. So hopefully you're looking at this and you're like, okay, I get it. So we are going to be graphing the parent functions of y is equal to the sine of theta and y is equal to the cosine of theta. And the way that we're going to do it is we are going to make a table of values to determine the graphs of each of them. Y is equal to the sine of theta and y is equal to the cosine of theta, and what they would look like. Now, because theta is an angle measure, instead of substituting values for theta like negative 2, negative 1, 0, 1, and 2 like we have for other graphs, what we're going to do is we're going to put in these critical values for theta. And those critical values are our quadrantal angles from the unit circle. That 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's go ahead and look at our first graph, which is for y is equal to the sine of theta. So we know that the sine, we're letting theta be 0 pi over 2 pi. There was an error with this, so we're going to write 3 pi over 2 right here. And I'm going to scribble this out, and we're going to write 2 pi right here. So I am going to put in all of the values that we had in our warm-up. So the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is back at 0. Let's go ahead and plot these points. So I'm going to plot 0, 0, pi over 2, 1, pi, 0, 3 pi over 2 is going down to negative 1, and then we have 2 pi, 0. And when I connect these points, I'm going to connect them like a wave. This is a wave, a nice, smooth curve. And we always highlight that first wave that we plotted. So that's going to be something that I'm going to be looking for. Where did you start your graph? Now, I want you to note that our graph doesn't stop because although we went around the unit circle one full time, we can keep going around the unit circle. So right here at 2 pi, where would our next point be? So our next point, we're here at 2 pi, would be where our y value would be 1. So we're going to draw an arrow pointing towards our next point, which is going to be 1. We can also go counterclockwise around our unit circle. So going counterclockwise, our next point would be at negative 1. So at negative pi over 2, we're going to plot a point down here at negative 1. Then at negative pi, our sine value is at 0. Then at negative 3 pi over 2, our sine value would be at positive 1. And then at negative 2 pi, we are back at 0. And we would anticipate that the next point would be right here at negative 1, so I'm going to draw an arrow pointing down. So we want to make sure that we have appropriate end behavior that is pointing towards where the next point is. We should have our graphs have these maximum and minimum points where it almost looks parabolic when you look at each of these individual. They should look parabolic to you. Please note that these graphs are not zigzags and not sharp. So they are not zigzags and they are not sharp. And so that is very, very important for you to know. So some characteristics about this graph that I need you to know and be able to identify is the amplitude. Now the amplitude is based on an a value, and that a value comes from the fact that we're going to be graphing sine functions in the form of y is equal to a times the sine of b times x minus h plus k. And the one that we just graphed is the parent function, where a, b, h, and k are either zeros or ones. In this case, our amplitude is based on the absolute value of a. So our amplitude talks about how high is our peaks and how low is our valleys, and that is going to be the absolute value of a, which in this case is the number 1. So it has a formula. It is 1/2 times your maximum value minus your minimum value. And it is always positive. So in this case, our maximum value, which we already know, is at 1. And our minimum value is at negative 1, which this graph has a range going from negative 1 to positive 1. Those are the only values of y that we're allowed to have. Our max is 1, our minimum is negative 1, so I have a minus negative, which makes a positive. Half of 2 is 1, and that is our amplitude. Our period, which a period represents how long it takes to go through one full cycle of sine. So a cycle of sine has a pattern of 0 up, 0 down, 0. So 0 up, 0 down, 0, going all the way across. So 0 up, 0 down, 0. Then 0 up, 0 down, 0. And so how long it takes to go through that is your horizontal distance. And it takes from 0 to 2 pi. So our period is 2 pi. And how we calculate 2 pi for our period, our period is equal to 2 pi divided by the b value. And so if our a value is what is controlling the amplitude, our b value, which I will use highlighter for, controls or helps to control our period. So in this problem, our b value is a 1 because there's an invisible number 1 right next door to sine. So that's going to be 2 pi divided by 1, which is 2 pi, and that's how they came up with that number. The next thing that we have is an axis, and in this case, our axis is going to be a horizontal dashed line located at y equals 0, and it is based on the k value. So it is at y equals 0. And it is based on k. And we always draw it as a horizontal dashed line, and it kind of separates the graph into two separate halves. And that would be considered our axes. Now let's go ahead and graph our cosine function. Our cosine function is y is equal to cosine of theta. And once again, we are letting theta equal our quadrantal angles again of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's go ahead and take a moment and let's go ahead and fill out this table. So the cosine of 0 we know is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Let's go ahead and take a moment and plot these points. So I'm going to start up here at 1, 0. So sine started at 0, 0, but cosine starts at 1, 0. And then we have pi over 2, 0. Pi is going to go down to -1. 3 pi over 2, 0. And then 2 pi is going up at 1. And it looks like it should be a V. But the way that we graph it is going to be smooth and curvy like a wave. So we want to make sure that we have that wave as a part of our answer. And we always highlight those first 5 points that you plot, and then you're telling me how you're expanding it. So we know that going around our circle, we're right here at 2 pi. If we were to continue going counterclockwise, we're right here up at 1. Our next point is going to be right here at 0. So I'm going to reach this max, and then I'm going to have an arrow pointing down. Please make sure that this max is a max and you're not having your arrow go up and then down, because that would be incorrect. We do not want to do that. On the other side, we are at 0 and we want to go down or clockwise to -pi over 2, and our x value is at 0. So connecting this, I'm at -pi over 2, 0. Then at -pi, we're going back to -1, so down here at -1. Then at -3 pi over 2, we're back up at 0. And then at -2 pi, we are back at 1. We've reached our maximum value, and our next point should be pointing down at 0. So that is how we graph our function. We have our initial 5 points, and then we expand it on both sides. Once again, our amplitude is how high is our peaks, how low is our values, and it's going to follow the exact same steps that we had up here. In this case, it's 1. Your minimum value and your maximum value are going to be at -1 and 1 respectively, with our range going from -1 to 1. So our domain is all real numbers because we have an arrow pointing to the left and an arrow pointing to the right. And our range, our most minimum point is a -1 and our most maximum point is a +1. When it comes to period, our period for a cosine function is still going to be 2 pi, and that is because period, once again, is 2 pi divided by our b value. So I want to bring to your attention that when I talk about a's and b's, I am referring to the general function of y is equal to a times the cosine of b times x minus h plus k. And that is where the a value, the number that's in front of cosine, affects your amplitude, and what affects your period is going to be that b value. Our axis is still going to be at y equals 0, and it is still once again based on k. And we always draw it as a horizontal dashed line. So to kind of recap on all of our characteristics, I have a table down here that kind of synthesizes the key characteristics of y is equal to the sine of theta and y is equal to the cosine of theta. This is parent function information only. So it is only for our parent function ordered pairs. Parent functions without any sort of extra numbers other than ones and zeros. So what I want you to note is that for each of the functions, let me back out just a little bit. There we go. For each of the functions, the range is going to go from -1 to 1, and that is for both of them. It'll reach a max of -1. This will reach a minimum of -1, a maximum of 1. The amplitude of a function's graph is half the difference of the maximum, capital letter M, and the minimum, little m. And that formula is 1/2 the max minus the min. It is essentially equal to the absolute value of A every single time. Now, each function is referred to as periodic, which means that the graph has a repeating pattern. And that repeating pattern for sine, once again, is 0 up, 0 down, 0. And for cosine, it is up, 0 down, 0 up. And that's what you're going to see from beginning to end. 0 up, 0 down, 0, 0 up, 0 down, 0. For cosine, it is up, 0 down, 0 up, 0 down, 0 up. So you're going to see that over and over again, and you're going to hear me say that throughout this lesson. Now, please note that the shortest distance, or the shortest repeating portion of the graph, is called a cycle. The horizontal length of each cycle is called a period. And a period represents how long it takes to go through that pattern of 0 up, 0 down, 0. And both sine and cosine graphs each have a period of 2 pi. It takes 2 pi units to go through that entire pattern. Next, the x-intercepts of y is equal to the sine of x occurs at 0, pi, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, et cetera, et cetera. Essentially, these are multiples of pi. So at multiples of pi, you're going to see that it's going to cross the x-axis. And then if you look at the x-intercepts of cosine, y is equal to the cosine of x, they are going to occur at the vertical axes, which is plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, et cetera, et cetera. And these are all multiples of pi over 2. So that is something to kind of keep in mind. And you might have a couple of problems pertaining to this type of information in your homework. So I just want you to have that awareness. And once again, this is all about the parent function. So what we're going to do on the next page is we are going to make adjustments to the amplitude and the period. And then we're going to talk about what those graphs are going to look like. So I want you to note that every A value is not going to be the number 1. Our A value is going to change. And when it changes, it affects the amplitude. So that A value of denotes a change in amplitude, how high our peaks are, how low our values are. And it is the number that's in front of sine of x and cosine of x. Think of amplitude like a vertical stretch of a graph. It's going to affect the location of the maximum value and the minimum value. When we change the period, what that means is that your B value, that's the number that is located right next to X. When that number is something other than 1, then our period will change. So since a normal period is 2 pi, we find that our period ends up being 2 pi divided by the absolute value of B. So once again, that is our formula that I need you to know and study. And that is that period is equal to 2 pi divided by the absolute value of B, which I am never going to give you negative values. So this, just know that you always are going to be dividing by a positive number. But I don't think that I give you any negative B values in this class. I want you to note, because these are all new vocabulary words, once again, what a period represents is how quickly a graph moves through one cycle. And when it comes to our table of values, we're not just going to be working with 0, pi over 2, pi, 3 pi over 2, and 2 pi, because those values actually came from our cycle. So since our normal critical values are pi over 2 units, what we're going to do is we're going to divide pi over 2 by b to come up with your new increments. So you're going to get your coordinates from your parent function, and then we're going to be making changes based on the b values to come up with our new increments, as well as our a value, and discuss your change in amplitude. So what that's going to look like is this. What I have is a general sine function and a general cosine function. And I am going to create a table of values, x's and y's. And this is going to represent the table of values that represent y is equal to a times the sine of bx. Now, this is one cycle of sine, and notice that it starts at 0, 0, and then it lands at 2 pi over b 0. That is one full cycle. And I want you to note that sine always starts at 0, 0. This is always the beginning of sine, 0, 0. And then it follows this pattern that I know that I have said before, and it is 0 going up to a max, and that max is an a value, back to 0, down to our minimum value, and our minimum value will be at negative a, and then back at 0. So 0 up, 0 down, 0. To come up with our x values, though, I want you to think we're going through and we want to plot these 5 points. And this point right here is 1/4 of our period. And I want you to think about it like going around a circle. When we went around a circle, we started off with 0, 0. And then our first point came up here, and that is going 1/4 of the unit circle. And then our point right here is half of the unit circle. This point down here is 3/4 of the unit circle. And then we're at the end of our circle. So just like that, if our period changes, our next ordered pair is going to be 1/4 times whatever our period is. And then the next ordered pair is going to be half, or x value will be 1/2 times our period of 2 pi divided by b. And then it'll be 3/4 times 2 pi divided by b. And then our last ordered pair is going to come from 1 times 2 pi divided by b. You know you did this correctly if that last x value is indeed your period. So whatever period you calculated it to be. Your y values, we're going to be following this pattern of 0 up to a, back to 0, down to negative a, back to 0. And that's how every single table is going to look like for y is equal to a times the sine of bx. So now let's go ahead and take a look at y is equal to a times the cosine of bx. We're going to create a very similar table of values, x's and y's, but this time around I want you to note that cosine starts right here at 0a. It does not start at 0, 0. It starts up. And our a value is going to be right here with our minimum being at negative a. So 0a is where we start with cosine. And then it's going to follow its own pattern of up, 0, down, 0, and then back up again. And so that is our pattern for cosine. And once again, I want you to notice that going around the circle or going through one cycle, we're going 1/4 of the way, half, 3/4, and then all the way. So that is 1/4 times 2 pi over b, half of 2 pi over b, 3/4 of 2 pi divided by b, and then 1 times 2 pi divided by b. And once again, that last number needs to be your period. You should see that every single time. Your y values are up 0, down to negative a, 0, and then back up to a. And that's what we're going to see every single time. So let's go ahead and actually hop into the graphs. We have a few examples. Here is example number 2. Example number 2 says, graph the function y is equal to 3 times the cosine of x. Sometimes it's helpful to rewrite it using a's, b's, h's, and k's. So I'm going to rewrite this as y is equal to 3 times the cosine of 1 times x minus 0 plus 0. And by rewriting it like that, we can clearly see that a is equal to 3, b is equal to 1, h is equal to 0, and k is equal to 0. A, B, H, and K. Our amplitude in this case is the absolute value of 3, which is 3. So our amplitude is 3. Our period is 2 pi divided by our b value. Since b is 1, our period is 2 pi. Our midline or axis is at y equals 0. And once again, that is based on the k value. So that k value is at y equals 0. And we're going to go ahead and graph that axis right away. So now what we want to do is we want to come up with our key points of our table. And because our function is cosine, that means that we're starting at 0 up at our a value, and our a value is 3. Then I'm going to come up with my x values by going 1/4 times our period. And our period in this case was 2 pi. So this 2 pi is what I'm going to be multiplying 1/4 by. I'm multiplying it by 2 pi. And 1/4 times 2 pi is 2 over 4, which is 1/2, so pi over 2. Then it's 1/2 times 2 pi, and half of 2 is 1, so 1 pi. 3/4 times 2 pi, that's 6 over 4, which is 3 pi's over 2. And then 1 times 2 pi, which is simply 2 pi. We should see that this last x value should match our period. Then cosine is following the pattern of up 0, down to -3, 0, back up again. So up 0, down 0, up. Now we've got to graph this. And one thing that is kind of tough is figuring out what your scale should go by. So when I talk about scale, I'm talking about either the lines in between or maybe like the solid tick marks. I personally like the solid tick marks, and that second x value, 9 times out of 10 is going to be what your x scale should go by. So what I mean by that is right here, I'm going to make at a solid tick mark a pi over 2. And then the next tick mark will be 2 pi's over 2, which is pi. Then the next tick mark will be 3 pi's over 2. And then the next tick mark will be 4 pi's over 2, which reduces to 2 pi. So that is all of the labeling that I need for your x-axis. For your y-axis, you can skip a line, you can go by ones. I like to stretch it out a little bit, but because this a value is already pretty large, I'm just going to count by ones. 1, 2, and here is 3. 1, 2, and here is -3. So now that I have my scale labeled, which I am going to be looking for that, we are now ready to plot these ordered pairs. So I'm going to plot 0, 3, pi over 2, 0, pi -3, 3 pi over 2, 0, and 2 pi, 3. And to the very best of my ability, I am going to connect these points, and I am going to highlight them. So we always highlight that first cycle of cosine. So when I highlight that first cycle of cosine, that tells me where I'm starting my graph, and then we must continue from end to end, because technically you can keep going around a circle left or right as many times as you would like. So my next point will be right here at 0. My next point after that will be down at -3. Then I go back to 0. Then I go up to +3. And then I go back to 0, and I'm going to connect with a smooth curve. My next point after 0 is going to be down at -3, so I'm going to have an arrow pointing down. On the other side, I'm at up. I'm not going to go up higher, so I'm going to go back to 0 and then down to -3 and back to 0. My next point will be up at +3, and you should see that it should be going, basically up 0, like your next one would be up 0, down 0, up 0, down 0, up 0, down 0, up 0, down 0, up. Okay, and that's what we should see, and that's what our graph would look like. So on your homework, I need you to highlight those initial points, and you must have an axis drawn as well, even if it is on the x-axis. All right, let's go ahead and do a few more problems. Example number 3. We have y is equal to y is equal to the sine of 3x. So sometimes it's helpful to rewrite this as y is equal to 1 times the sine of 3 times x minus 0 plus 0. So our a value is 1, our b value is 3, our h value is 0, our k value is 0. The amplitude is the absolute value of 1, which is 1. Our period is 2 pi divided by 3, and that's just going to be 2 pi's over 3. And our midline is at y equals 0. And that midline, once again, is based on our k value. Eventually, these will change in our next lesson. So y equals 0, and I am going to graph that as a dashed line going straight across. Now we have to come up with our 5 key points. And since this function is sine, I'm going to start off by graphing or plotting 0, 0. We're identifying that we're starting with 0, 0. Then I'm going to take my period, and I'm going to go 1/4 times my period of 2 pi divided by 3. Basically, the 2 over the 4 becomes a 2 in the denominator. And so this becomes, or you can also view it as 2 over 12, which reduces to pi over 6. Then half of 2 pi over 3, the 2's cancel away, and we have pi over 3, which is basically 2 pi's over 6. And then I have 3/4 times 2 pi over 3. And the 3's cancel and the 2's, this becomes basically pi over 2. This is 1 pi over 6, 2 pi's over 6, 3 pi's over 6. The next one should be 4 pi's over 6, which reduces to 2 pi's over 3. And I'm telling you that because our scale is going to be based on that second x value. So also, this is a sine function. So we're going to follow the pattern of 0 up to 1, which is our a value, 0 down to -1, and back to 0. And these are going to be the points that I need to plot. Once again, that second x value is going to be what our x scale is going to be. And I like to use the solid tick marks. And so what I mean by the scale is at the solid tick marks, I'm going to make this a pi over 6. The next one is 2 pi's over 6, which reduces to pi over 3. The next one is 3 pi's over 6, which reduces to pi over 2. And the next one is 4 pi's over 6, which reduces to 2 pi over 3. My y scale needs to be, we're going up and down to 1, so some people like to skip lines. I know I do. I'm going to skip a line and make this 1, and down here a -1, just so that you can kind of get that graph looking really nice. And I'm going to plot these points. We are starting with 0, 0, pi over 6, 1, pi over 3, 0, pi over 2 down to -1, and 2 pi over 3, 0. So here is my first cycle of cosine. And I'm going to get out my highlighter, and I'm going to highlight it because this is where I am starting my graph, and I need to see that highlighter on your homework. Then from here, we're going to continue the pattern. So we were at 0, up, 0, down, 0, up. And we go all the way to the very edge. I always have kids that like to stop right here. That's not what we do. We keep it going. My next point, I've reached my max, has to be pointing down. Over on this side, We're at 0. We need to go down to -1, back to 0, and then up to +1. And I'm going to connect these points with a smooth curve. I've reached to my max. So I'm going to have an arrow pointing down, and then that's what this graph is going to look like. So what I would like you to please do at this time is I would like you to please pause, and I would like you to please go ahead and try example number 4, where it's kind of like bringing it all together, and let's see how well you do. All right, so hopefully you paused the video and you tried this on your own. So in this problem, we have y is equal to 1/4 times the sine of pi times x minus 0 plus 0, where our a value is equal to 1/4, our b value is pi, our h value is 0, and our k value is 0. So our amplitude is the absolute value of 1/4, which is 1/4. Our period is 2 pi divided by pi, which is just the number 2. Your period does not have to have a pi in it. And then your midline is at y is equal to 0. So let's go ahead and graph that. So we always do our midline right away. From here, we have to come up with our table of values. We have 0, 0, because it is sine. And then we're going to do 1/4 times 1 times 2. That's 2/4, which is 1/2. 1/2 times 2, which is 1. 3/4 times 2, which is going to be 6/4, which is 3/2, or 1.5. And then 1 times 2, which is 2. Then our y values are 0 going up to 1/4, back to 0, down to -1/4, and back to 0. Our scale for x is going to be 1/2. And so I'm going to label my x scale as 1, like every solid tick mark is going to be 1/2, 1, 3/2, and 2. And then I have my max values going to 1/4. So what I think I'm going to do is I'm going to count 4, 1, 2, 3, and I'll make this 1/4. 1, 2, 3, and down here I'll make it -1/4. So that scale is going to be going by 1/16. And now I am ready to start plotting my points. So I'm going to start at 0, 0, 1/2 going up to 1/4, back to 0, 0, down to -1/4, back to 0. So this is what my graph looks like. And I'll make sure that I highlight that. Those are my first 5 key points. And we always want to make sure that we are highlighting those first points. It's very important. It's going to really come into play for our next lesson. So then I'm going to go up, and then 0, down, and then back to 0, and up again. And connect these points, keeping it smooth, keeping it curvy. I've reached my max. My graph is going to curve down. Then from here, I'm going to go down, back to 0, and up again. And I've reached my max, so I have an arrow pointing down. All right, I would like you to go ahead and pause the video again, and I would like you to please go ahead and try example number 5 on your own. And when you have an answer, please go ahead and restart the video, and we will see how well you did. Okay, let's go ahead and take a look at this one. So I'm going to rewrite this as y is equal to 2 times the cosine of pi times x minus 0 plus 0, which means that my a value is 2, my b value is pi, my h value is 0, my k value is 0. So these are all of my values. The amplitude is the absolute value of 2, which is 2. My period is 2 pi divided by our b value, which is pi, so therefore we have 2. Our midline is at y equals 0, so I'm going to go ahead and graph that. There we go. It's always a horizontal dashed line. And now I need to come up with my table of values. My table of values this time is going to start at 0a, which is 0,2, because I function as cosine this time. And I'm going to do 1/4 times 2, which we already did as 1/2. 1/2 times 2, which is 1, 3/4 times 2, which is 3/2, and 1 times 2, which is 2. Now, when it comes to this work above, if you've already done it in a previous problem, don't do it again. It's okay. But if you want to, because you're that visual person, you have to show that work every single time, then that is fine as well. We're following our cosine pattern of up 0 down to -2, 0 back up to 2. And these are going to be the points that we plot. Once again, our x scale is going to be that first ordered pair, or that first x value, that second x value of your table. So every solid tick mark, I'm going to make it a 1/2. And then 2/2 is 1, 3/2, and 4/2, which is going to reduce to 2. And then I can go by every individual line, or I can skip a line and make this 1 and make this 2. Down here, this would be -1 and -2. Now, whatever you make your scale go by, I recognize that everyone might choose something different. That is okay. I am very open to that. So here we go. I'm going to plot 0, 2, and then I have 1/2, 0, 1, -2, 3/2, 0, and then 2, 2. And there is my first cycle, and I'm going to make sure that I highlight it because that was the first one that I plotted. And then from here we expand. So up, 0, down, 0, up again, and this is always on those solid tick marks, and then back to 0. My next point would be down at -2. So now I'm going to come on over here, and we were already up. The next point is 0. We're going to go down to -2, back to 0. And what you should see is that these graphs should look very similar to each other. The only thing that is changing is just what we're making our scale go by. But otherwise, these graphs are going to be the same graph every time. So that's the reason why I really need to see what that scale is. Because once we hop into some transformations in our next lesson, you're going to see, oh, I really do need to make sure that my scale does make sense, especially if we have a shift left or right. So let's go ahead and talk about our last idea, and that is about models. So trigonometric models. So the periodic nature of trigonometric functions is useful for modeling oscillating motions or repeating patterns that occur in real life. So some examples are sound waves, the motion of a pendulum, the seasons of a year. These are just some of the examples. In such applications, it is useful to study the frequency of a model. So what frequency is frequency gives the number of cycles per unit of time. It is the reciprocal of the period. So frequency is 1 over period, and if period is 2 pi over b, and that means it's b divided by 2 pi. So in example number 6, we want to write a sine function with an amplitude of 3 and a frequency of 1,000. So what I'm going to write is, I know because my amplitude is 3, A is equal to 3. My frequency is 1,000, which means that I don't know what B is. That's what I need to find. So I do know that 1,000 would be equal to B divided by 2 pi. This is a proportion, and we can make that 1,000 be over 1, and we can multiply both sides basically by 2 pi, or we can do cross product. And we find that B is equal to 1,000 times 2 pi is 2,000 pi. So that's what we found B to be, 2,000 pi. So now that we have that, our sine function would be y is equal to 3 times the sine of 2,000 pi. And that, pi x, 2,000 pi x. So whenever you do a function, you need to have two variables in there. And that is our answer. So now let's go ahead and look at example number 7. It says a sound consisting of a single frequency is called a pure tone. So if it has a single frequency, it's called a pure tone. An audiometer produces pure tones to test a person's auditory functions. Suppose an audiometer produces a pure tone with a frequency F of 2,000 hertz cycles per second. The max pressure P produced from a pure tone is 2 millipascals. Write a sine function or sine model that gives the pressure P as a function of time t seconds. So what that means is that we want to, instead of y is equal to a times the sine of bx, we're going to write a model that's going to be p is equal to a times the sine of b times t. So we're using p's and t's instead. Regardless, do you see how we have a max pressure of our pure tone is 2 millipascals? That max and 2 means that our A value is going to be 2. But our B value, we do not know what that is, but we do know that the frequency is 2,000 hertz. And so therefore, we're going to calculate what our B value is, the same way that we did in example 6. We're going to go 2,000 is equal to B divided by 2 pi. Another way, instead of cross product, is you could simply multiply both sides by 2 pi. And that will get the B value alone. 2 pi times 2,000 is 4,000 pi is equal to B. So now that you know what B is equal to, we can now put it into our function of P is equal to 2 times the sine of 4,000 pi times T. And that is your model, as well as the end of today's lesson. If you have any questions over anything that I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.